When we charge a capacitor, we need to put a resistor in series with it to limit the current that's going to flow. This resistor and capacitor value are going to determine how fast the capacitor charges. We can calculate the time using T equals C times R. So in this circuit, we've got a capacitor of 10 microfarads. Remember, that's 10 times 10 to the minus 6 because of the micro. And we've got a resistor of 2 megohms, which is going to be 2 times 10 to the positive 6 for mega. The formula is T equals C times R. So we get 10 times 10 to the minus 6 times 2 times 10 to the 6. And you should get 20 seconds for that. Now this 20 seconds doesn't mean this capacitor will charge in 20 seconds, because the total time it takes to charge will be 5 times this T. So 5 times 20 to give us 100 seconds. So what we're saying there is, if we connect this 20 volts with 2 megohm resistor and a 10 microfarad capacitor, the current will flow around there, it will charge this capacitor, and it will take 100 seconds to charge. We can see that on this graph. Here's our time along the bottom there and our volts across the capacitor here. After 20 seconds, which was our first time constant, there's a big rise in voltage and it reaches 63.2% of its maximum value. Now this is a fixed figure for all capacitor charging, 63.2% after one time constant. It will then take another 4 time constants to reach the maximum value. So in all, it will take 5 time constants to reach maximum, 100 seconds. The current that's flowing when it's charging, we can calculate using Ohm's law. We've got 20 volts and 2 megohms. We know I is equal to V over R from Ohm's law. So we've got 20 divided by 2 million, or 2 times 10 to the 6 for 2 megohms. And that gives us 10 microamps, 10 millionths of an amp. This will be the maximum current that will flow. This is a graph of the current. There's our 10 microamps there. When we first start charging the capacitor, we get a big rush of current, but after one time constant, that current has dropped by 63.2 to this value of 36.8. It will take a further 4 time constants to reach 0. So again, 100 seconds to reach 0. There's no current flowing because we know now the capacitor is fully charged. The discharge voltage will drop from the maximum voltage here, and in one time constant it will drop 63.2% to 36.8% of that value. It will again take another 4 time constants to reach 0. So after 5 time constants, the voltage is 0 and the capacitor is fully discharged. The discharge current is the same as the charge current. There's our maximum 10 microamps. There's the big falling current after 1 time constant, and then it takes a further 4 time constants to reach 0.